Hi guys, welcome back to the channel. My name is Jag, and in today's class we are going to continue with our grade 11 content, and we're going to move on to the topic of hydrates. Alright, so with that, let's get started. What we are going to start off with is basically how to name the hydrates. Okay, I have to make sure I'm using the prefix method. Okay, so first off, what is a hydrate? A hydrate is basically molecules of water, and they're going to be attached to the actual compound. Okay, so I'm going to do an example here. Say I have calcium and then SO4, and then there's going to be like a dot like this, and I'm going to put 2H2O. Okay, so it looks something like this. Okay, and what you're going to do is I'm just going to name what the compound is. Okay, so I can see I have an ionic compound at the beginning. How I'm naming this is basically calcium sulfate. Alright, and you see that there's a dot in the middle, and that shows that there are two molecules of water that are attached to this compound. Okay, so the two, if we're using the prefix method, the two represents di, so I'm going to put di hydrate. Does everyone see that? Okay, so again, the prefix method, just like when you're naming the molecular compounds, okay, those are the same prefixes we are going to use here. Let's try another example here. So say I have CaCl2, okay, and I'm going to put the dot, okay, and then 2H2O. Okay, so again, there can be as many molecules of water, okay, attached to the compound, okay, so that doesn't matter. So let's try naming this here. So Ca is calcium. Okay, sometimes they can be polyatomic compounds as well. Okay, here I can see it's a simple ionic compound. Okay, so Ca is calcium and Cl is chloride. Okay, so chlorine, but remember I have to add IDE at the end, okay, of the compound. And again, here I have two molecules of water attached, so I'm going to put dihydrate. Okay, so hydrate just represents water, okay, and depending on the number of molecules of water attached to the compound, I'm just going to put in basically that prefix in front of the hydrates. Okay, so you can see it is actually pretty simple. Okay, let's try one more example here where we're just naming the compound. I'm going to take this off. Okay, and we're going to change the number of molecules of water here. Okay, so let's do LiCl2. Okay, and dot, and let's do 4H2O. Okay. Alright, so say I'm naming this one more time. Okay, a simple ionic compound. Li is lithium. Okay, and Cl is chlorine. I'm going to add IDE at the end, so it becomes chloride. Okay, 4 molecules of water here. The prefix for 4 is tetra. So I'm going to put tetrahydrates. Alright, does everyone see how to do that? Okay, so one more time, we're going to use just the prefix method here for the number of molecules of water. Okay, and when you name the compound, again, we're just naming it how we do the regular naming method. Don't worry about the numbers that you see over here. And again, that's just associated with the charge, and we were using the crossover method to cross it to the opposite side. Alright, I'm going to take this off. Okay, for just a second here. Okay, and we're going to just write out the prefixes. Okay, and the prefixes you should know should be just up to 10. Okay, so mono is 1. Okay, and di is 2. And you notice that they are basically very similar to that you see in math. Tri is 3. Tetra is 4. Okay, and we have some room, so I'll put penta is 5. Alright, and I would make sure I am memorizing these. Okay, so hexa is 6, hepta is 7. Okay, and let's do it up to 10 there. So octa is 8, nona is 9, and deca, again, just like in math, represents 10. Okay, so I would memorize them up to 10, okay, because there can be, again, any number of water molecules that are attached to any type of compound here. Okay, Alright, so let's try slightly different. We're going to try writing out the actual formula of the hydrate. Okay, and I'm going to give it to you in words. Okay, so let's try that because it's a little more trickier. So let me take this off here. Okay, so let's put example. Okay, so I'm going to give this to you in words. So let's try magnesium. Okay, sulfate. Okay, and I'm taking just questions from the textbook here. Alright, and let's try hepta. Okay, heptahydrate. Okay, so don't worry about how long the name is. We shouldn't be getting scared here. We are just going to break it down. Okay, so I'm going to start off with magnesium. Okay, sulfate. And again, if you see polyatomic ions, depends on your teacher whether or not they want you to memorize these polyatomic ions with the charge. I know there are some teachers who do want you to do that. And again, if you do a lot of practice with naming compounds, you'll just actually know what the formulas are, okay? So the most important polyatomic ions that I would remember would include something like nitrate, carbonate, okay, phosphate, chlorate, sulfate. And the reason for that is these compounds are very commonly used in the laboratory, all right? So I would know basically the compound formula for that. So sulfate is SO4. I should note that the charge is 2 minus, okay? Phosphate is PO4, the charge is 3 minus. And these charges are really important when we're doing the crossover method to write the actual formula for the compound, okay? So let's try this one here, okay? So magnesium is Mg, okay? If you're looking in the periodic table, make sure you use a periodic table that gives you the charges, okay? Here I'm going to just write out the charge right beside it. So magnesium is 2 plus, okay? Sulfate is SO4, and just like I mentioned right now, the charge is 2 minus, okay? And we're going to do this in steps, okay, so everyone can follow along. And when you see that the charges are the same here, okay, I see magnesium is 2 plus, sulfate is 2 minus, the charges are going to cancel out, okay? And I don't need to cross it over here, okay? So just like in math, it's kind of like I'm reducing these charges. Okay, so what it becomes is MgSO4. I'm going to put the dot, okay? And now we're looking at basically the hydrate here. And it says heptahydrate, okay? So hepta is 7 molecules of water. And we put 7 H2O. Okay, so this is basically the formula here. It's magnesium sulfate, heptahydrate. Okay, are there any questions there? Okay, good. So let's try maybe just a couple more examples here. Okay, so again, I'm going to take this off. Okay, and I'm going to keep changing the number of water molecules attached to the compound. Okay, so we get like really good with naming the compound as well as just writing the formula. Okay, so let's try this one. Okay, so in the book it says barium hydroxide, okay, barium hydroxide octahydrate. And the good thing about using the prefix method is it's not kind of like the first time you're seeing this, okay? We covered that when we were naming also the molecular compounds. And just because the prefixes are also the same as the ones used in math, it's kind of easy to remember them. With that, let's try this question, okay? So first we are going to try barium hydroxide, okay? So again, in this textbook, it is page 98, okay? And this is the McGraw-Hill Ryerson Chemistry 11 textbook, okay? But again, just look for the page that has all of the polyatomic ions, okay? If you're not still sure about the compounds and the number of charges that it has, okay? I would keep using a table like that for reference. You can even go into Google and just put polyatomic ions PDF, and usually a table will show up, okay? And that is sufficient to answer these questions. All right, so let's try barium. Is Ba if you're checking in your periodic table. Okay, the charge for barium is 2, okay? Or if you actually remember the group that each of these elements falls into, most of the cases will have like the same charge for the element depending on which group it falls under, okay? And then I have hydroxide, which is OH, and the charge is 1 minus. Okay, does everyone see that? I always do it like this, and I always put the charges on top of each of the elements or like the polyatomic ions. And that way I can use the crossover method. Even when I'm checking my answer, say at the end of a test or a quiz, I can make sure that it is the right answer. Okay, so we're going to cross over the charges. So just like this, okay? I'm going to put an arrow here, okay? Just to show you what barium hydroxide, what the formula is here. So it's going to be Ba, like 1, okay? And I can see this 1 is coming from the OH hydroxide here, okay? It's coming in the middle. I'm going to put the OH, okay? And for the barium, you see that the barium is 2 plus here, and the 2 plus is going to the opposite side. So it's going to be like that, okay? Again, I don't need to actually write the 1, so I'm just going to move the barium over. So just like in math, don't write the number 1, okay? Whenever you're doing the formulas, that's just unnecessary. Okay, the number has to be greater than 1 in order for you to put it down, all right? So this is actually the formula for barium hydroxide, okay? We can all see that. And now we're going to do the molecules of water. It says octahydrate, which means there are 8 molecules of water. Okay, is everyone good? So this is the formula for barium hydroxide and octahydrate, okay? So let's try one last question here, okay? I think we are getting a really good hang of it. Okay, so I think writing the formulas is a little bit more trickier than you just writing out what the compound is in words. And that's just because we have to use the crossover method one more time. And this is really good review for naming the compounds. And again, naming compounds and writing the formulas has to be really, really good. And you have to be very good at it because when you go through the types of reactions, okay, you won't be able to write out chemical reactions if your formulas are wrong, okay? So with that, let's try this last example here. So I'm going to take this off, okay? And let's try sodium, okay, carbonate. Okay, let's change the number of water molecules here. Okay, we're going to use Deca Hydrate. Okay, so one more time, I'm going to write out the elements with the charges. So sodium is Na, the charge is 1 plus, okay? So carbonate, anytime it ends in name ends in ATE, I know it's a polyatomic ion, okay? So carbonate is actually CO3. And then you can check it in the table one more time. The charge is 2 minus. I'm going to cross the charges over. Let's make an arrow so everyone can see that, okay? And the formula now becomes Na. So this is actually Na2CO3, okay? So I can see that the 2 minus is actually coming from the carbonate and it's going between the sodium and the carbonate. The 1 plus charge right here, okay, that's coming from sodium, is actually going to the opposite side of the carbonate. But again, because the charge is just 1, I'm not going to include that in my formula, all right? And if we are looking now, Deca Hydrate, make sure you're always putting the dot, okay? The dot just represents that these molecules of water are attached to the actual compound, okay? And so Deca, like we said when we wrote out our prefixes, Deca is 10, and hydrate is H2O. Okay, so this is our formula here for sodium carbonate, Deca Hydrate, okay? So that looks good, and that brings this video to an end. And today we covered chemistry 11, basically just naming the hydrates and writing out the formulas. This is actually very important as well. And in the next video, what we're going to be covering is determining the formula of a hydrate, all right? And if you don't know actually how to write the formula for the hydrates, you won't be able to determine the formula. And this is more like in a lab setting, okay, where you have this compound, and how you get rid of the water molecules is by basically just heating this whole compound, and then the water molecules are going to evaporate, and you can only be left, what you'll be left with is just this ionic compound, all right? So thank you for watching this video. If you like this content, please make sure you're subscribing to the channel and click on the like button below because it makes a really big difference. And I will see everyone next time. Thanks. Bye.